Today we are going to discuss some details about the organic compounds containing nitrogen. We are going to discuss it in the form of few questions and answers. One of the important nitrogen compounds, one group of important nitrogen compounds are amines, but equally important are some nitro compounds. So let us discuss the first question relating to an organic nitrogen compound containing a nitro group, namely nitrobenzene. The question asked is, what are the various reduction products of nitrobenzene under various reduction conditions? The first thing to be conveyed by means of this question is, there are, depending upon the reduction conditions employed for the reduction, different types of reduction products can be obtained. First one is reduction of nitrobenzene in acid medium. It's only a generation of hydrogen, but the hydrogen can be generated by a number of methods, namely tin metal and HCl, or zinc metal and HCl, or iron and HCl. Any one of these elements, when they react with hydrochloric acid, will generate hydrogen. So it is only reduction by means of hydrogen in acid medium. So in all these cases, the product obtained is aniline. Nitro group is straight away reduced to aniline. This is in fact one of the methods of making aniline from benzene. Benzene is converted to nitrobenzene. This is actually known as nitrobenzene. This compound is nitrobenzene, and this is known as aminobenzene or aniline. So this is aniline and this is nitrobenzene. And nitrobenzene can be reduced under acid conditions to give rise to aniline. So this is one of the very important reactions of nitrobenzene, and one of the very important methods in turn of the formation or the synthesis of aniline. So this will be the first one, that is a reduction product. Various conditions. Now we are going to look at 2 or 3 different conditions, and this is the first condition. The second condition is, the same nitrobenzene can be reduced, as for example, the nitrobenzene can be reduced in alkaline medium. Instead of reducing it in the acid medium, now we are going to reduce it in alkaline medium. The zinc metal can be used. Zinc is a metal that will liberate hydrogen in acid as well as in alkaline conditions. Therefore, when it is treated with sodium hydroxide solution in alkaline medium, this will give rise to diazobenzene. It will give rise to a compound known as diazobenzene. This type of group is being introduced. This is only under alkaline condition. It is also possible the same thing can be treated with zinc dust in the presence of sodium hydroxide and heating. These are all the conditions that is being employed. The same zinc and sodium hydroxide will give diazobenzene. On strong heating conditions, it is further reduced to give rise to hydrazobenzene. This double bond gets reduced. It will give rise to, this is known as hydrazobenzene. I will write the names of this. This is known as diazobenzene because the 2 azo groups are present as a double bond here. Here it is known as hydrazobenzene. Azo means nitrogen. Hydrazobenzene. The difference between the two being, under the milder condition, this will give rise to diazobenzene. Under strong alkaline conditions, this will give rise to hydrazobenzene. So we never get aniline here, we get hydrazobenzene under alkaline condition. So the condition is changed from acidic to alkaline. Instead of giving aniline, this gives rise to hydrazobenzene. It is also possible the same nitrobenzene, which I have written on the board, will give rise to, when it is reduced by means of zinc as a reducing agent. In all these cases, zinc happens to be a common metal, one in the presence of acid, the other in the presence of alkali. Now it is present in neutral medium, ammonium chloride. The zinc metal present in the presence of ammonium chloride, and on mild heating will give rise to partial reduction occurs actually. So the nitrobenzene becomes phenyl hydroxylamine. This is known as phenyl hydroxylamine. This is a phenyl group. This is hydroxylamine. So this is the product that is obtained. So the nitrobenzene is reduced to aniline in acid medium, is reduced to hydrazobenzene in alkaline medium, and then in neutral medium it is reduced to phenyl hydroxylamine. This is actually the basis of one test for the nitro group, the presence of the nitro group in an aromatic compound. As for example, the presence of nitrobenzene can be tested by means of one reaction which is known as Mulliken and Barker's reaction. This is referred as Mulliken and Barker's reaction. This Mulliken and Barker's reaction is based on this reaction. You reduce nitrobenzene not under acid or alkaline conditions but under neutral conditions. The product obtained is phenyl hydroxylamine, which has some reducing properties. This on reaction with silver nitrate or tolerance reagent, alcoholic silver, ammoniacal silver nitrate, will lead to the formation of a black precipitate. This is the basis of what is known as the Mulliken and Barker's reaction, which is a test for the nitro group. So these are all the various reduction products of nitrobenzene. So this is a very important part of our study of organic nitrogen compounds, and we start with the nitro compounds and then we proceed to the other more important nitro compound, namely the amines.